All right, this is Mr. McCord's ICP class, Unit 5, assignment number 4. We're looking at a different kind of chemical called covalent compounds. So up to this point, we've talked about ionic compounds, where things stick together because of the attractions between charged atoms we call ions, but not everything works like that. If you start looking up formulas for different chemicals that you kind of find around, you'll wind up finding things that don't have charges canceling out, or a give and take of electrons wouldn't be able to make them happy. Like in the case of this guy right here, I've got phosphorus and chlorine coming together to make a compound, but phosphorus and chlorine both want to gain electrons, so it's not like they can, give and just get more. So that kind of bonding, ionic bonding, doesn't work for everything. Instead, sometimes we have to share electrons, okay? So, in ionic compounds, we show that give and take in those charges with brackets and then pluses and minuses for charges. In covalent compounds, we show a sharing of electrons by lines like this and this and this and this. Okay? Dots still show leftover electrons, just like we use dots to show valence electrons in ionic compounds, but they're not going to be as useful to us here. They're just kind of there to be a correct structure, a correct picture of the molecule that we're making, the new compound that we're making. Okay? So in this case, to figure out how something is going to share electrons, it's a lot tougher than figuring out the give and take. There's not as many hard and fast rules to cancel charges and stuff, since there are no charges in covalent compounds. We're just sharing electrons and everything gets along. So for this class, we're not really going to worry about the dots on covalent compounds. All we're going to worry about is how many atoms make up a covalent compound. All right? We can use that to figure out the formula, how many of this element and that element there are to make up that compound, and also the name. How do we put that in words? Okay? So for this first structure, I'm going to look at this. I've got 2 oxygen atoms here, and I've got 2 atoms of hydrogen. They're all connected together by lines, so this is a covalent compound. I've also got some extra dots here on the O's, but I don't need to worry about that. All I'm going to worry about is how many O's and how many H's do I have in this structure. Okay? That will tell me my formula. Okay? Now, typically also, figuring out what element comes first in the formula and name is a little bit tricky. Rule of thumb is usually the thing that's in the center, right? Like the O's here or the P here, or whatever's on the left, going left to right, like this H compared to the F, is what we go with first. But typically on our assignments in our class, I'll tell you what comes first because there are some oddball ones. Okay? So, rule of thumb, whatever's in the middle or whatever is kind of on the left is usually what comes first. But if not, then we will write out kind of what you're supposed to put first. So in this case, we want oxygen first in the formula in the name. Okay? So the formula is right now the symbols. Oxygen symbol is O, and then we also have some H's. Okay. And just like with ionic compound formulas, I need to have a little number down here, a little subscript to say how many O's and how many H's I have. All right? I have 2 O's here, so I'm going to put a little 2 down at the bottom of this to show that I've got 2 O's. And I've also got 2 H's, so I want to write a little 2 down by the H to show that there are 2 H's. All right? So this is my formula for this covalent compound. It's just as easy as counting up the letters, 2 O's and 2 H's. Again, note that I did not count up the number of dots or the number of lines, okay? All that matters for the formula and therefore for the name of a covalent compound is how many atoms of each element there are. I'm only counting letters. I'm not counting lines. I'm not counting dots. Okay? To change this into a name, I'm just going to do, again, oxygen first. So I start with oxygen. I use a prefix to say how many there are. In this case, there are 2. The prefix for 2 for covalent compounds is di. Di. So dioxygen is the first part. The second part, I'm taking hydrogen, but I have to chop the end off and make it IDE. So hydrogen is going to become hydride. Okay, and I also need to write and show if there's a number of hydrogens in there. In this case, there are 2. So again, the prefix for 2 is di, so I want to put di in front of that one also. Okay, so this structure here, this covalent compound, has the formula O2H2, and the name, how we say that in words, is dioxygen, for the 2 O's, dihydride, for the 2 H's. Okay, let's do another. All right, this guy right here, so he has phosphorus and chlorine in it, and we want to put phosphorus first. Okay, so for my formula, P is the symbol for phosphorus, and I just have 1 of them, so I'm just going to put a little 1 down there. All right, I've got 3 chlorine atoms in this, so the symbol for chlorine is Cl, and I've got 3 of them, so I need a little subscript 3. Right? And you may remember we don't really need to put 1s like this here, so I'm going to get rid of it. So my formula is just going to be PCl3 to show the 1 phosphorus atom in the 3 chlorine atoms I have in here. Okay, so my formula is PCl3. I'm going to scoot this over a little bit closer to it. They're all kind of strung together. All right, PCl3. So to put that into the name form, I'm going to have phosphorus again, comes first. Okay. Now, the prefix for this could be mono, because I've only got 1 of them, but we never use mono for the first element. So I don't want to do that. I don't want it to be monophosphorus. We only use mono if the second element shows up only once. So this is just going to stay phosphorus. The second guy, chlorine, is going to have the N chopped off to become IDE. So chlorine is going to become chloride. And I also need a prefix to say how many there are, right? Since there are 3 chlorines, the prefix for 3 is tri. So this is going to be tri, T-R-I, chloride. Trichloride. So the name for this whole compound, this whole covalent substance, is phosphorus trichloride, and its formula is PCl3. Okay, let's do one more. Okay, this one we're doing hydrogen first. Okay, well, I've just got 1 H. I've just got 1 hydrogen, so it's going to be H. And then I've only got 1 F. Again, I'm not counting the 7 dots. I'm not counting, 6 dots. I'm not counting the dots. I'm not counting lines. I just want to know there's 1 H and there's 1 F. Again, not technically wrong if you put 1s down there, but we typically don't do it. So just HF is our formula for this compound. To put that into words, just like before, I don't want to use mono for the first element. I don't want to say monohydrogen. We just don't do it. It's kind of clunky to put it on the first element. So we're just going to call the first part hydrogen. All right. We can use mono for the second part. Okay. So I can change this to become from fluorine to fluoride. and I can put the prefix mono on the front for the one fluorine there is. Mono is the prefix for one. So it's going to be monofluorine becomes fluoride, so monofluoride. All right, and that's my name for this compound. So this covalent substance right here has the formula HF, and we call that hydrogen monofluoride.